Alright, in the first part of this lesson, we're just going to focus on taking the word equations and transferring them into a written formula equation, and then we're going to balance the formula equation. The other stuff in this worksheet where it's identifying types of chemical reactions, you know, the synthesis, decomp, single replacement, double replacement, combustion, all that stuff, we'll do that at a later time. So just hold on to this worksheet. We'll do the first part, just writing and balancing, and then we'll get to the second part later. Okay, the first thing we need to do is we need to find out the formula for all these compounds. Sodium is just going to be Na. The iron 3 oxide, as you guys recall, that Roman numeral 3 indicates the positive oxidation state of the metallic element, and so iron has a 3+ charge. Oxygen, as you know, always is 2-, and so iron 3 oxide has a formula of Fe2O3. So essentially 3 comes here, 2 goes here. And then sodium oxide, sodium is 1+. Oxygen, as we know, is always 2-, so they're both representative. The formula is going to be Na2O. And so to write these in a actual formula, so let's see, we have sodium reacting with iron 3 oxide, so that's going to be Fe2O3, and it's going to yield or produce sodium oxide, so Na2O plus iron. Alright, and so that's the formula equation. Go ahead and pause the video here for a moment, and then I'm going to balance it. Okay, let's do our atom inventory. On the reactant side over here, we happen to have 1 sodium, we happen to have 2 irons, and we have 3 oxygen. On the product side, it looks like 2 sodiums, iron we only have 1, and we have 1 oxygen. Alright, so in looking at this, let's see, I want to go ahead and fix the sodium first. And so if well actually no, I might want to wait for the sodium because notice I have sodium by itself over here. So let's actually, iron is the same way. Let's look at the oxygen maybe first. Oxygen on the reactant side, there are 3 and there is only 1 on the product. So if I put a 3 here, that's going to fix the oxygen. And now the sodium, 2 times 3, that gives me 6 sodium. Well, I can easily fix that by putting a 6 in front of the sodium. And let's see, the only thing that isn't fixed is going to be the iron. That's easy enough. We'll put a 2 here. And so the coefficient should be 6, 1, 3, 2. Okay, in this problem, there's a couple of things that might have thrown some people off. You have hydrogen bromide forms from hydrogen gas and bromine gas. And so what you have to realize is that this first thing that it's mentioning, this hydrogen bromide, that is actually the product because it is forming from. Alright? And so the actual reactants are the hydrogen and the bromine. The other thing you have to remember, both hydrogen and bromine are diatomic, right? Go to 7, make a 7, or Brinkelhoff, however you want to remember it. Those two elements are never found alone. And so for hydrogen gas, it's got to be H2, and then bromine is Br2. So both diatomics, and they're going to form hydrogen bromide. Hydrogen bromide is just hydrogen and bromine. Hydrogen's 1+, bromine's 1-, so it's just simply HBr. This one, I'm not even going to pause it for the balancing because you notice there's 2 of each on the reactant. All you have to do is put a coefficient of 2 in front of it, and that's it. Okay, this problem is kind of similar to the previous problem in the fact that it's telling you the products first. So silver metal and chlorine are going to be the products. They're forming from silver chloride. Because silver is always 1+, and chlorine is always 1-, the formula for silver chloride is simply AgCl. Okay, and so that is turning into silver metal is just going to be silver. Okay, it's just silver is a metal. Don't be thrown off by the word metal. And then chlorine gas, once again, you have to be aware or pay attention to Brinkelhoff, right? That's one of the go to 7, make a 7. It is diatomic, so there should be 2 chlorines. Once again, this one's fairly simple to balance. I'm not going to really do an inventory. You can see there's 2 chlorines as a product, so if I put a 2 in front of the silver chloride, all I have to do is put a 2 in front of the silver, and that's that. Okay, on this problem, you'll have to forgive me. Whenever I type this in, it looks like it's putting the numbers in as subscripts, and then when I load it up here on the old iPad to produce the videos, it, for whatever reason, makes those subscripts back into the regular line of text. So that ethane should be C2H6, the 2 and the 6 should be subscripts. So you're going to see that again, but I guess that's life. All right, so carbon dioxide and water are produced. So those 2 things are the products. They are being produced. Ethane is a hydrocarbon. It's also a organic compound made from once living things. Notice carbon and hydrogen. So the first reactant is ethane, C2H6, and it's reacting with oxygen. Once again, oxygen, one of those diatomics, Brinkelhoff. Go to 7, make a 7. And so carbon dioxide, CO2, and then good old water, H2O. So go ahead and take a moment. Go ahead and pause the video. Take some time. Try to balance the formula. Okay, let's do our atom inventory. You'll notice over here on the reactant side I have 2 carbons. There are 6 hydrogens and 2 oxygen. On the product side, I have 1 carbon, 2 hydrogens, and there are 3 oxygens. Let's go ahead and start with the carbon. I have 2 and I have 1, so I need to put a 2 in front of the carbon dioxide. It's going to make this 2. Oxygen then becomes 2 times 2 is 4, plus that 1 on the hydrogen, so that gives me a total of 5. Okay, hydrogens I have 6 and I have 2, so if I put a 3 here, that's going to make this 6. The oxygen I have 2 times 2 for 4, plus the 3 on the water will give me a total of 7. Okay, now I have that classic scenario where carbon's balanced, hydrogen's balanced, and oxygen is not. I end up with an odd number of oxygens, and you'll notice no matter what number I put in front of O2, any number times 2 will end up being even. How do I get an odd number? Well, there is an odd number that when you take it times 2 is 7. That, or just a number, sorry, it doesn't have to be odd, but that number is 3.5. But guess what? You can't have halves. Halves are no bueno. That's Spanish for no good. How do I get rid of the half? Answer, I've got to double it. So if I double 3.5, 3.5 times 2, that'll make this 7. All right? Well, if I double one of them, you have to double everything to be even. And so this 1 doubled becomes a 2. This 2, when you double it, becomes a 4. And then this 3, when you double it, becomes a 6. And so for the balanced formula, the coefficients should be 2, 7, 4, and 6. Okay, on this problem, let's look at some of these formulas real quick. Calcium oxide, calcium is representative, it is always 2 plus. Oxygen is always 2 minus. And so if they're equal and opposite, they cancel. It's just CaO is calcium oxide. Water is H2O, but let's see, calcium hydroxide. Calcium is 2 plus. Hydroxide, and that was a plus. Hydroxide is 1 minus, so when these combine, CaOH, parentheses 2. You need the 2 there, or the parentheses before the 2, to show that there are 2 hydroxide groups. If you don't have the parentheses, it looks like calcium and water, and that is not calcium hydroxide. Okay, so there are the formulas. So let's go ahead and write it. It says calcium oxide reacts with, so calcium oxide is a reactant. We're going to react this with water, so good old H2O, and it's going to form calcium hydroxide. All right, atom inventory. On this side, it looks like I have 1 calcium. Looks like I have a total of 2 oxygens and 2 hydrogens. Let's see, on this side I have 1 calcium, 2 oxygens, 2 hydrogens. Hey, it's already balanced. That's okay. Don't worry about it. That happens on occasion. So you didn't make any mistakes. Everything looks good. So this one, as is. Okay, this problem, we're starting with calcium hydroxide. We just had that in the previous problem, so we already know this formula is CaOH parentheses 2. Hydrochloric acid, it was nice enough to give you the formula for that. It's HCl. We don't do acid nomenclature, but that's it. And it produces calcium chloride. Calcium is always 2 plus. Chloride is 1 minus, so the formula is CaCl2. And then, of course, we have water. So there is our formula equation. Go ahead and pause the video for a moment, and then we'll do the balancing. Okay, atom inventory time. Let's see. Calcium, it looks like there is 1 calcium. Let's see, oxygen I have 2. Hydrogen I have 2 plus 1, so I have a total of 3 hydrogen. And there should be 1 chlorine. On the product side, it looks like we also have 1 calcium. Oxygen is only 1. Hydrogen, I have a total of 2. And then it looks like I also have 2 chlorines. Calcium looks fine. Oxygen doesn't. I have 2 and I have 1. So let's see here. I'm going to put a 2 in front of the water, which is going to make this 2. But at the same time, it also is going to change my number of hydrogens to now 4. All right. Calcium's fine. Oxygen is fine. The hydrogen is not. Notice I have 4 and I have 3. The 3 are separate. You may struggle with that, but if you look, it kind of gives you a hint. If you look at the last thing, there's 1 chlorine and 2 chlorines. If I end up putting a 2 here, that fixes the chlorine. But then look what it also did to the hydrogen. I have 2 in the calcium hydroxide, now 2 in hydrogen, so I have a total of 4. So just by fixing one of it, it automatically fixed the other. Coefficient should be 1, 2, 1, 2. All right, in this problem, we've got to write some formulas. So let's get that out of the way first. Iron 3 nitrate. So iron 3, once again, that doesn't mean there are 3 irons. It just means the oxidation state or the charge of iron is 3 plus. Nitrate, as you know, is NO3. It's always 1 minus, so the formula for iron 3 nitrate is FeNO3 parentheses 3, so the 3 comes down. Lithium hydroxide, lithium is 1 plus, hydroxide is 1 minus, so it's LiOH. Lithium nitrate, lithium's 1 plus, nitrate's 1 minus, so it's LiNO3. And then iron 3 hydroxide, let's do that one. So iron 3, and then hydroxide is OH with a 1 minus, so it should be FeOH parentheses 3. So let's go ahead and write the formula equation down. So let's see, iron 3 nitrate is a reactant, so let's start out with FeNO3 parentheses 3, and it looks like it's reacting with the lithium hydroxide to produce, let's see, lithium nitrate we decided was LiNO3, and then iron 3 hydroxide, which is going to be FeOH parentheses 3. Okay, so go ahead and pause the video here for a moment and give you guys a chance to balance the formula, then I'll show you the solution. Alright, it's time to do the atom inventory. Let's count the number and type of elements present. It looks like on this side there is 1 iron. I'm going to leave the nitrate together because notice nitrate appears both on the reactant and product side. So I'm going to just leave it as one entity. So I'm going to say there are 3 nitrate groups. Let's see, we have 1 lithium, and same thing with the hydroxide. A hydroxide appears on both sides. So I'm going to say there's just 1 hydroxide. We can do the exact same thing for the product side. So I'm going to do iron first. There happens to be 1 iron. Nitrate, it only looks like there is 1 on this side. Lithium, there is only 1. And then it looks like there are 3 hydroxide groups. Alright, so 3 nitrates and 1 nitrate. So if I put a 3 here, That's going to make nitrates 3, but at the same time lithium becomes 3. Well, that's no big deal, because all I have to do is put a 3 in front of the lithium hydroxide. Notice everything is now balanced. The coefficient should be 1, 3, 3, 1. Okay, we're heading down the home stretch. We have iron metal. That's just iron. Reacts with oxygen once again. Hopefully you recall oxygen is O2. It's a diatomic. Iron 3 oxide we've already done, so I'm not going to fret too much about this. It's Fe2O3, right? 3 from the iron comes down behind the oxygen. 2 from the oxide goes behind the iron. All right, atom inventory. There is 1 iron. There are 2 oxygens. On this side we have 2 irons and 3 oxygen. All right, let's see. I'm going to leave the iron alone because iron is by itself, so that'll be real easy to fix at the end. Oxygen, I have 2 and 3. A common factor is normally 6. So if I put a 2 here, iron becomes 4. Oxygen becomes 6. I need to put a 3 in front of the oxygen to make it 6. And we'll put a 4 in front of the iron to balance it out. So the coefficient should be 4, 3, 2. Alright, I don't know what's going on here. So not only did it mess up the subscripts and put a big space in between oxygen and gas, but oh well, we won't let it bother us. So let's see. In this one, it says carbon dioxide and water. These are produced, so that means these are products. Sucrose there, that's table sugar. We're going to start out with it. That is a reactant. So we have C12H22O11. So there's our sucrose. Reacts with oxygen. Once again, oxygen is diatomic. Brinkelhoff, or go to 7, make it 7, however you want to do it. And then the products are CO2 and H2O. Okay, so there is the formula equation. Go ahead and pause the video and take a few moments here, do your atom inventory, and balance that formula. Okay, atom inventory. Let's see here. We happen to have on the reactant side, there are 12 carbons. Hydrogen, it looks like there are 22. Oxygen, I have 11 plus those other 2. That's going to be 13 oxygen. On the product side, let's see. We have 1 carbon, 2 hydrogen, and 3 oxygen. All right, so 12 and 1. If I put a 12 in front of the carbon, this is going to make this 12. Oxygen now becomes 2 times 12, which is 24 plus 1. We all of a sudden have 25. Okay, let's look at this. Hydrogen is 22 and 2, so an easy way to make this even is put an 11 in front of the hydrogen. That's going to make this 22. Now let's look at our oxygens. We have 12 times 2, which is 24, plus 11. That should be 35. All right. Now, this looks like an insurmountable task because you look over there and you're like, 13 and 35, holy schmoly. I can't think of a common factor those two numbers go into. But what you have to recognize is that we're not going to mess with these 11 over here, because notice these 11 are attached to the carbon and the hydrogen, and we already have all these things balanced. So we're not going to mess with these 11. So I can essentially discount this 11. So out of these 35, 11 of them I don't have to mess with. Well, that means I only have 24 to produce out of this thing. Well, that's easy enough because I know that 12 times 2 is 24. So if I put a coefficient of 12 in front of the oxygen, it should now be balanced. So the coefficient should go 1, 12, 12, and 11. All right, we made it. So let's just look at a couple of formulas here real quick. Lead 2 nitrate, as you guys recall, that simply means lead has a 2 plus charge. Nitrate is NO3, it's always 1 minus. So lead 2 nitrate should be Pb NO3 parentheses 2. Lead 2 oxide, this is just telling me lead is 2 plus, oxygen is 2 minus, so that should be PbO. Nitrogen dioxide should be NO2, and then oxygen gas is O2. So let's write our formula equation here. So let's see, we're going to have lead 2 nitrate, so PbNO3 parentheses 2. And it said this is breaking down, so that's the only reactant. And what it is turning into is lead 2 oxide, so PbO plus nitrogen dioxide plus oxygen. Awesome. Okay, go ahead and pause the video here for a minute and do your atom inventory and balance this, and we'll call it a day. All right, atom inventory time. On this side, I have 1 lead. Nitrogens, it looks like I have 2 nitrogen. Oxygen, I happen to have 6. Okay, on the product side, it looks like there is 1 lead. Nitrogen, there is only 1. Oxygen, I have 1, 2, 3, 4, 5. So a total of 5 oxygen. All right, let's fix this. Nitrogen, I need to put a 2 in front of here, which is going to make this 2. Let's see, oxygen now becomes 1, and then 2 times 2 is 4, so that's 5, 6, 7 for those final 2. All right, and let's see here. This is another one of those places where everything is balanced, so we've got the lead and the nitrogen all ready to go. The oxygen is just off, and we've got an oxygen sitting over here kind of by itself, but notice it's not oxygen, it's O2. And so, you know, you might think to yourself, man, this would be super convenient if I could just get rid of one of those 2's, then it would reduce my number of oxygens by 1 and we'd be balanced. Well, unfortunately, you can't do that. But what we can do is that we can put a coefficient in front of it. We could put it a coefficient of 1/2 right there in front of the O2. Well, if we put the 1/2 in front of O2, it would be balanced. Unfortunately, we can't have fractions or decimals. They always have to be whole numbers. So how do I get rid of a half? Answer, you double it. And so if I take 1/2 and double it, that's 1. And if you double one of them, you have to double everything. This 2 becomes a 4, and this 1 becomes a 2, this 1 becomes a 2. And so the coefficient should go 2, 2, 4, 1.